Greetings to everyone. In this video, we are going to learn about deterministic finite automata. It's commonly called DFA. So this is the architecture of a deterministic DFA. So here, if we are giving some input, the state will be changed from the initial state, current state to another state. And here the starting state, this is it is represented as a circle with an arrow, and the final state is represented as a double circle. So next slide, this here the DFA reads an input string one symbol at a time from the left to right. So here, after reading the complete string, it either accept or reject the string. Okay, so if it is the string is accepted by this DFA, it is moves to the accepted state. Okay, but the string, it will read the string from left to right and one symbol at a time. Okay, then at last it will rejects or accepts the string. So in the next slide, so DFA has a 5 tuple specification. So mainly there are the states and alpha, that is alphabet, starting state, final state, and transition function. Okay. So we are representing by 5 components. M is equal to Q. Q is the finite non-empty set of states. And this alphabet, sigma is alphabet, input alphabet. It contains the sequence of input symbols, and S is the starting state. Okay, it's strongly mentioned. So S is the starting state, and F is the final state, and del means the transition function. So transition functions means the transition from one state to another. This function is representing the transition rules. Okay. So in the next slide, so here, before creating a DFA, we define the set of states and input symbol. So the DFA can only read the symbol from its alphabets. Okay. So Q is the set of states, right? So in this, in the previous slide, we have mentioned that 5 tuple. Q represents the set of states. So here in the circle, inside the circle, we have given the value 0 and 1. So now here it is 0 is the state and 1 is the other state. So either we can use Q naught or A, B, Q naught, Q1. So these are also we can use as an example for the states. So here Q is equal to 0 and 1. So here the states are 0 and 1. And S is the starting state and F is the final state. If we are using 0 is the starting statement, we have to represent an arrow with this circle. And 1, if it is a final statement, we have to represent it with a double circle. And here A and B is the input symbols. So we are representing this input symbol in alphabet. That is sigma is equal to A comma B. Okay. So next slide. So here it represents the transition function. Transition function tells the DFA where to move next based on the current state and the current symbol, input symbol. Okay. So here the transition function, it tells the DFA where to move next based on this current state P and the current symbol sigma. Okay. So here the transition function is represented as del of P comma sigma. So here the machine must go next based on its current position and the symbol is just string. Okay. So here the del is Q. Q means state and this is sigma is alphabets and moves to the next state. Q is also a next state. So based on this state and the input symbol, it moves to the next state. Okay. So in the next slide, it is how to represent the transition diagram. So transition diagram means a graphical representation of a DFA. So here the circle represents the states and the arrow represents the transitions and the double circle represents the final state and the circle with an arrow represents the starting state. Okay. So the circle represents the state and the arrow represents the transition and the circle with an arrow represents the starting state and double circle represents the final state. Okay. So next, this is the transition table. it shows all the state changes in a tabular form. It helps us to understand the DFA quickly. So here in the transition table, we have to represent the states and inputs. So here in our example, the states are 0 and 1 and the input symbols are A, comma B. Okay. So for example, A and B. So in the state, if you are in the state 0 and reading the symbol B, it moves to the state 1. Okay. So how we have to understand means, so this is the state with the input symbol A, it moves to the same initial state, that is self transition. And if you are reading while it's in the state 0, while reading the symbol B, it moves to the state 1. And the next one, if the state in the state 1, if you are reading the symbol A, it moves to the self transition, it's the same state. If we are reading, if the DFA reading the symbol B, the state 1 is transferred to the state 0. Okay. So this is the transition table and the previous slide represents the transition diagram. So here this DFA can be represented using some formal notation, that is transition table and the transition diagram. Okay. So here in this formal specification, it has 5 tuples, that is Q and the alphabet, starting state, final state, and extra one is transition. So for the transition, we are representing a transition table and the transition diagram. This is the example, refer it. Okay. And the next slide. Here, the string is accepted if the DFA ends in the final state. Okay, after reading the entire input string. Okay, so here the states are Q0, Q1, Q2, Q3, and P. Okay, so here the input symbols are A and B. After reading the string, it is moves to the final state. So here in this example, the string is A, B, A, B. Okay, so the string is moves from state to another state, and until the final state reaches, it is accepted the string. Okay, so del of Q naught comma X. X represents the symbol and P represents the state. Okay, then in the next slide. So here the DFA starts at the starting state and loads the input string and prepares to process the symbols one by one. Okay, so here in this example, the Q naught is the final state and also a starting state. Okay, so starting state is represented by a circle with an arrow, and the final state represented as a double circle. In this example, Q naught is act as a starting state and as well as the final state. Okay. Okay. So next, the step-by-step string processing. The DFA reads each symbol and applies the transition rule and moves to the next state until all symbols are processed. Okay. So here, del of Q naught comma Q1. The current state is Q naught. Reading the symbol 1, it moves to the state Q1. Okay. So Q naught, it moving the symbol 1, it moves to the Q1. And del of Q1 comma 1 is equal to Q naught means at the state Q1 is reading the symbol 1, moves the state Q naught. Okay. So how we are representing this transition means by using the transition function del of that state comma the reading symbol, and this is the transfer state. Okay, the next state, it represents the next state. Okay, thus we have to represent all this transition function from the above example. Okay, then here the reaching the end of the taper, that is del of Q3 comma 0, it moves to Q1, and del of Q1 comma 1, it moves to the Q0. Okay, so when after reading the entire string, the DFA reaches the final state. In the above example, the Q0 is the final state. So it reaches the final state, right? So if it is an accepting state, the string is accepted. So in the above example, the string is 110101. So we have started from the starting state Q0, and after transitions, it moves to the Q naught state. So in this example, Q naught is act as a starting state and final state. If it reaches the final state Q naught, the string 110101 is successfully accepted. Okay. The next slide, it's an empty string property. That is, empty string is represented by this epsilon. Okay, so empty string is represented by epsilon. When the DFA receives an empty string, it remains in the same state. That is, there is no input symbol. If there is no input symbol, means it's an empty string. So if your DFA receives an empty string, it remains in the original state. So how we can represent the transition function for this empty string means del of q comma epsilon is equal to q. Okay, so that means if a DFA receives an empty string, it remains in the same state. Okay, the empty string is represented as a epsilon. The next one, extended transition function. So extended transition is represented as a del cap. So the extended transition function processes an entire string and determines the final state after reading all the symbol. If del means only it processes a single letter, single symbol. Okay, but del cap, that is extended function, process the entire string. Okay, so del cap of q comma xa. This is the string sequence of symbols xa. Then we have to write as del cap of q comma x of a. First we have to calculate the transition function of del of q comma x. Then we have to calculate the answer from this transition comma a. Okay, so extended transition is represented as del cap. It is process the entire string. Okay, so in the next slide, it's a regular languages. The set of strings accepted by this DFA is called as regular languages. The string which are moves to the final state that is accepted by the DFA is called as regular languages. And here the DFA is widely used in computer science applications. Okay, so here we are representing this language L of M is equal to W, that is set of string del cap. Del cap means extended function. Extended function means this process the entire string. So q naught comma w. Okay, w is the set of string that belongs to the final state. If it is reaches the final state, then the DFA is accepted, right? So the particular language, the particular string is regular language. Okay, thank you.